Hello everyone, my name is Matthew Polishchuk, and in this video I'll be going over the MEXT Undergraduate 2017 Math B exam. So I'll solve and explain every question. Please know that this is part of a series, and in the Math B 2019 video I give a bit of extra helpful info at the start. But to save time, I'm just going to go right into the questions for this video. So first is question 1, which says log base 10 of 4 over 5 plus 2 times log base 10 of 5 times the square root of 5 is equal to blank. So for this one, all you need to know are the simple log rules. So the log addition rule, subtraction rule, power rule, stuff like that. All we need to do is manipulate this equation a bit so that it becomes something we can easily analyze. So to start, let's use a power rule to move this 2 right here into an exponent. So this becomes log of 5 times the square root of 5 to the power of 2. And so by raising it to the power of 2, we get rid of the square root, and that just becomes log of 125. Also, all of these are log base 10, which is what the question gives. I'm just not writing it to save time. And at least where I'm from, if you have a log with no base, then it's assumed that it's base 10. And I'm also not going to explain each step in my process since it's pretty straightforward, but of course you can pause the video if you want to follow exactly what I'm doing. So next, notice that log of 125 is the same as log of 5 cubed. Also, log of 4 over 5 is just log of 4 minus log of 5. So we can then use the power rule to simplify this into log of 4 plus 2 times log of 5, which becomes log of 4 plus log of 25, which finally becomes log of 100, since 4 times 25 equals to 100. And since this is a log in base 10, log of 100 is just equal to 2, and that is the answer to this question. So next is question 2, which says the set of all solutions to the inequality 2 cosine of x minus the square root of 3 less than 0, with 0 is less than or equal to x, which is less than 2 pi, is the interval blank pi is less than x, which is less than blank pi. So for this, you need to be able to analyze the trig function, and you need to know the trig values of special common angles. So to start, we can change our inequality a bit to make it easier to work with. So we have 2 times cosine of x minus the square root of 3 is less than 0. So instead we can say that cosine of x is less than the square root of 3 divided by 2. Hopefully you can recognize this as one of these special angles, specifically 30 degrees or pi over 6. So what that means is that the cosine of x must be less than cosine of 30. So if we draw a unit circle, we can mark this angle right here, 30 degrees. Also, if we look at what a cosine function looks like, you see the value goes down as the angle increases from 30 degrees. So that means that as we increase the value of x, the cosine function will get smaller, which means it will satisfy our inequality, since of course we have that cosine of x must be, cosine of x is less than the square root of 3 over 2. So the angles that cover all of this area is good, so we can fill in all of that. Then in both of these quadrants, cosine is negative, so of course it also fits our inequality. And so for the last quadrant, it's pretty much the same as our first quadrant. So cosine of 330 degrees, or 11 pi over 6, is also equal to the square root of 3 over 2. So for all angles less than 330 degrees, it fits our inequality, and you can also see that from the drawing, right? So at this point right here, that is equal to the square root of 3 over 2. As you increase from that, it gets bigger, so that doesn't fit our inequality, but anything less than that does fit our inequality. So there you go. All of this shaded area fits our inequality, and of course the question only asks from between 0 and 2 pi, so we don't need to go further than this. So what that means is that 1 over 6 pi is less than x, which is less than 11 over 6 pi, and that is the answer to this question. So next is question 3, which says if square root of 2 minus 2a is equal to a, then a is equal to blank. So this one is pretty simple. We just need to solve for a. So to start, we're going to square both sides to get rid of the square root. Now, you might be thinking that you need to use an absolute value here since we squared both sides, but that's actually not necessary, and you'll see why later. So anyways, if we move all the terms to one side, we get a quadratic with a squared plus 2a minus 2 equals to 0. And so we can use the quadratic formula to solve for a. So I'm not going to go through all the steps here because it's just, some basic math, but basically, we get that a equals to -1 plus minus the square root of 12 divided by 2. And we can simplify that to get that a equals to -1 plus minus the square root of 3. So we of course have two possible solutions. -1 plus the square root of 3 and -1 minus the square root of 3. However, only one of these answers is even possible, because if we look at what we started with, we will see that this square root right here equals to a. Now, the square root of a real number cannot be negative. It must be equal to a positive number. So therefore, a must be a positive number. So if we go back to our two possible solutions, the only possible answer is a is equal to -1 plus the square root of 3, which is positive since the square root of 3 is bigger than 1. -1 minus the square root of 3 is clearly negative, right? Because these are both negative terms. And so that's not a possible answer. So that's why we didn't need the absolute value, since, we got two answers here, but only one of them is possible anyways. So a equals to -1 plus the square root of 3, and that is the answer to this question. Next is question 4, which says the line through 2 points, -1, 0, 0, t, intersects with the unit circle x squared plus y squared equals 1 in one point a, b, away from the point -1, 0. Then a equals to something. So this question looks pretty complicated, at least I thought so when I first saw it, and the wording definitely doesn't make it easy either. So here, when it says one point a, b away from the point -1, 0, what it means is that there is a point a, b that the line intersects the circle at, and it is away from the point -1, 0, meaning it is a different point than the point -1, 0. So there are 2 points that the line intersects the circle at, -1, 0 and a, b. So hopefully that clears up any confusion that you may have had, since this wording really confused me at first. So to recommend, as always, I start by drawing a diagram. So here we have our circle, x squared plus y squared equals to 1. And then here we have our line. So the line intersects the circle at point -1, 0, right? That's given in the question. And it also intersects with the point a, b. And it goes through the point 0, t, which again is given in the question. So to start, we can find the slope of this line using rise over run. So rise between the 2 points, -1, 0 and 0, t, is t minus 0. And the run is 0 minus -1. And that just equals to t. So we know the slope of this line is equal to t. And we know that the y-intercept of our circle is also t, because it equals to t at x equals to 0. That's given in the question. So the equation of our line is y equals to tx plus t, or it equals to t times x plus 1. So now we can plug this expression for y into the equation of the circle. So we have x squared plus t times x plus 1 squared equals to 1. And so we expand all this to end up with, this equation at the bottom. And, again, pause if you want to see all my steps, since I'm not going to explain every single one just to save time. Anyways, what you will notice is that once you expand everything, you can actually make this quadratic function in terms of x. So the a value of this quadratic function is 1 plus t squared, the b value is 2t squared, and the c value is t squared minus 1. And that all equals to 0. So we can use the quadratic formula. And remember, we took the equation of our circle and we plugged the equation of our line into it. So now by doing this, we are finding the values of x at which our line and our circle intersect. So we do the quadratic formula, and you'll notice that, at first the square root looks really messed up, but actually a lot of the terms cancel out. So, once you expand a little bit here, you will see that inside of these brackets, you'll see that t squared cancels out with minus t squared. And then you get this, and then you see that 4t to the fourth cancels out with minus 4t to the fourth. And so we end up with just the square root of 4. And so we get this right here. And then if you divide the numerator and the denominator by 2, then we just get negative t squared plus minus 1 divided by 1 plus t squared. And the question asks us for a as a fraction with the denominator 1 plus t squared. So that's how we know we're definitely on the right track. So we have two solutions, right? This can be either plus 1 or minus 1. So to determine which one is correct, let's go back to our diagram. So remember, these solutions give us the x value at which our line and our circle intersect. We already know one of them, which is negative 1, 0. So we're trying to find the value of a, which is the x value of the other intersect point. What's important is that we cannot have an x value that is even smaller, or I guess even more negative than negative 1. Because the circle, of course, just has a radius of 1, right? X squared plus y squared equals to 1. So any x value smaller or more negative than 1 has no chance of intersecting the circle at all, right? If we had a x value like somewhere over here, obviously that can't intersect the circle since the circle stops at negative 1. So that means that a must be bigger than negative 1, right? Which means that out of our two solutions, let me scroll down to those. Out of our two solutions, the one for a must be the one of plus 1. Because if we do minus 1 here instead, we get a smaller value. And that smaller value corresponds with the intersection point negative 1, 0. So a must equal to negative t squared plus 1 divided by 1 plus t squared. So for our final answer, as they ask for in the question, it's a equals to 1 plus 0t plus negative 1t squared, all divided by 1 plus t squared. And that is the answer to this question. So next is question 5, which says that the sum from k equals to 0 of the binomial 10 choose k equals to blank, where n choose k equals to n factorial over n minus k factorial times k factorial. So this is a weird question. You need to know that the symbol at the start means a sum. It's a sigma. So it is the sum of 10 choose k, where k equals to 0, then 1, then 2, then 3, so on until 10. Also, if you have no idea what n choose k means, don't worry. I'll explain at the end of this question. It doesn't actually really matter. You also need to know that the factorial is when you multiply all the numbers before and including it. So 6 factorial, which is just 6 exclamation point, is equal to 6 times 5 times 4 times 3 times 2 times 1. That is what a factorial is. And if you know these things, then technically you can solve this question. And I say technically because you kind of can't actually, and you'll see why in a second, but I want to explain it. So here I wrote out a little bit, right? We have 10 choose 0 plus 10 choose 1 plus 10 choose 2 plus ... all the way to 10 choose 10. And those equal to these expressions right here, right? 10 factorial over 10 minus 0 factorial times 0 factorial, which, by the way, 0 factorial equals to 1. And yeah, technically, you could solve for all of this. But if you try this, you'll quickly realize that it's really hard, and it's going to be difficult to do this by hand, right? We have, this should be a 10 right here. But, we have 1 plus 10 plus 9 times 10 over 2, which isn't too hard. Then you have 8 times 9 times 10 over 6, and then you'll have 7 times 8 times 9 times 10 over like 24 or something like that. I don't know. Either way, it gets, way too complicated, and there's basically no way you can do this on paper. So actually, the way to solve this question is, unfortunately, to just have memorized the solution to the sum from k to 0 of n choose k. the sum from k0 to n of n choose k. And you'll see right here that it equals to 2 to the power of n. So for this question, that would be 2 to the power of 10, since the sum is from 0 to 10. You might already be able to solve that in your head, but in case you can't, an easy way to do that is to just break up 2 to the power of 10 into 2 to the power of 5 times 2 to the power of 5, which is 32 times 32. And you can just multiply that on paper to get 1024, and that is the answer to this question. So yeah, this question basically just relies on you knowing the summation of binomial coefficients. In my case, I had no idea what this was before I started studying for the MEXT exam because I never learned it in high school. But here's something positive to keep in mind. If you get a question like this on your exam where you have no idea what it's even saying because you've never learned it in school, then chances are everyone else in the room with you also has no idea what the question is saying, right? Since you're all from the same place and you probably all have similar curriculums. And so at least for the first screening, you're only competing against other students in your country. So you shouldn't be too bummed out if you get a question where you have no idea what it even means, because you're probably not the only one. So you're not actually losing any marks when compared to the other students writing the exam with you. But if you do know what this means, then I think this would be an easy question and a few free marks. Also, to explain what I mean by n choose k, what that means is if I have n things and I pick out k of them, how many different combinations of things can I pick out? So for example, let's do 4 choose 2. So I have 4 objects and I pick out 2 of those objects. And how many different combinations can I choose those 2 objects? So our objects are A, B, C, and D. And the ways we can choose them out are AB, AC, AD, BC, BD, and CO. This should say CD, not CB. So that means that, we have 6 different ways, which means that the answer to 4 choose 2 is equal to 6. And if you plug in the numbers 4 and 2 into the equation that the exam gives with the factorials and whatnot, you will in fact get the answer 6. And also, to be clear, the order of what you choose doesn't matter. So, BA is not different than AB, and it will not add to the sum of possible ways to choose 6 things. But, and I guess that's a pretty helpful thing to know in general, but for this question, you wouldn't really be able to actually use that. But yeah, that is the answer to question 5. So next is question 6, which says, let x, y, and z be natural numbers with x is less than y is less than z. If 1 over x plus 1 over y plus 1 over z is equal to 1, then x, y, z is equal to blank, blank, blank. So for this question, you kind of just need to do a bit of problem solving. Also, I don't think there's like a real systematic way to solve this. In my case, I just tried numbers until I got something that worked. And at first that might sound kind of sketchy, but if you actually try it, you'll realize that this question can be solved pretty easily. So x is a natural number, meaning a positive integer, and y and z are both greater than it. So to start, I'm just going to make x equal to 1 and see what happens. So we get 1 over 1, and we still have 1 over y plus 1 over z. So clearly this cannot be correct, since 1 over 1 just equals to 1 already, but we need all 3 of our fractions to add up to 1. And remember, our numbers are all natural numbers, which means y and z must also be positive. So clearly x cannot equal to 1. Next, let's try x equals to 2. So in this case, our fraction with x is 1 over 2, so that still works, since that's less than 1, and we can still add to it to get to 1. So now let's try the next possible y value, which is 3, since y must be greater than x. In this case, we get 1 over 2 plus 1 over 3, which adds up to 5 over 6. Again, this is less than 1, which means so far this still works. And now we just need to choose z so that we sum up to 1. And hopefully you can just see that if you add 1 over 6 to 5 over 6, you get 1. And therefore, z must equal to 6. And so this is our final answer. X is equal to 2, y is equal to 3, and z equals to 6. So yeah, it's not actually that hard to find the answer. And like I said, I don't think there's a real systematic way to answer this. You kind of have to, guess numbers and use a little bit of logic in terms of realizing that each fraction must be less than 1 in order to add them all up to 1, and also, starting from 1 and working your way up, because if you just, guess numbers at random, you never figure this out. But hopefully that's pretty easy. after my explanation. Next is the section 2 question, which says, suppose that the parabola y equals to x squared and a line L have two intersection points a comma a squared and b comma b squared with a is less than b. Fill in the blanks with the answers to the following questions. Let S be the area of the region bounded by the parabola y equals x squared and the line L. Express S in terms of a and b. Also, the second part says when the line L is perpendicular to the tangent line to the parabola y equals x squared at the point b comma b squared, express a in terms of b. So to answer this, you need to know a bit about integration and using derivatives to find a minimum or maximum. So to start, you should always draw a diagram. So we have the parabola y equals to x squared here in green. We also have this line in blue, and it intersects at 2 points, a comma a squared and b comma b squared. And since the second part of the question asks about when the line is perpendicular to the tangent of the parabola at point B, I drew that in here as well, right? So this red line here is the tangent to the parabola, and the blue line is perpendicular to it. So we want to find the area between the parabola under the line. So, you know, this area over here. So so that is an integral from x equals to b to x equals to a, and it's the line minus the parabola. So we're going to find the area under the line, and we're subtracting from it the area under the parabola. So of course that means we need to find the equation of the line. So to start, we can use rise over run to find the slope. The rise is b squared minus a squared, and the run is b minus a. Notice that b squared minus a squared is a difference of squares, so it can be written as a b minus a times b plus a, and then b minus a cancels out in the numerator of the denominator, so the slope is just b plus a. Then we can use the point slope form of a line. So for that, I'll use point A. So y1 is a squared, and x1 is a. And so if you take this, expand it, and then simplify, you end up you find that the equation of line is y equals to bx minus ab plus ax. So now our integral looks like this. And this just uses the basic power rule. Of course, remember that this is an integral with respect to x, right? It's dx. So you end up with this expression right here from b to a. And now you're just plugging in values. So of course, make sure to be, very careful. It's really easy to make a small mistake somewhere along the line, and then, your entire answer will end up being wrong. So with all the expanding and simplifying, which I'm not going to go through all of it, you can just, pause the video if you want to see it. You end up with this. And you might think that this right here is the final answer, but actually this can be simplified even further. So if you factor out 1 over 6, you'll see that these terms in here are actually just the expanded form of b minus a cubed. And so the area S is actually equal to 1 over 6 times b minus a cubed. If you don't recognize this, then it might be worth reviewing something called the binomial theorem. In my case, this was never taught in school. I think they just kind of expect you to catch on to on your own. But basically, if you have a plus minus b to a certain power, this pyramid right here will give you the coefficients of every term. Let me zoom out here so you can see the whole thing. So a plus minus b to the 0 has a single term with a coefficient of 1, since of course anything to the power 0 is just 1. A plus minus b to the first power is just 1. And 1, since, the first power doesn't do anything, it's just a plus minus b. A plus minus b squared gets you the coefficients 1, 2, 1. This is probably the one you're most familiar with, right? Since a plus b squared is equal to a squared plus 2ab plus b squared. So the coefficients are 1, 2, 1, just like this pyramid, and so on. And the way you progress this pyramid is by adding the two numbers above it. So this number is a 2 because there's two 1s above it. These are 3s because there's a 1 and 2 above them. This is a 6 because there's two 3s above it, and so on. And so for our question, you will notice that the coefficients in our terms are 1, 3, 3, and 1. And that corresponds perfectly to the coefficients of a plus minus b cubed. So the power in our and the powers in our question also correspond. So it goes from b cubed to ab squared to a squared b to a cubed. So there's a specific and pretty simple pattern that the binomial expansion goes through in terms of powers of terms, and I think the easiest way to show that is with an example. So right here, I've expanded a minus b to the power of 4. So if you look at our pyramid, first of all, we see the coefficients should be 1, 4, 6, 4, and 1. And as for our powers, it's very straightforward. So at the beginning, the first binomial term, in our case a, will have a power that will have the same power as what's outside of the brackets here. So in this case, 4. So we have a to the 4th. And then the other term, which in our case is b, will just have a power of 0. And then for each term after that, the power of a will decrease by 1, and the power of b will increase by 1. So now it's 4 times a to the power of 3 times b to the power of 1. So it went down. So for a, it went down from 4 to 3, and for b, it went up from 0 to 1. And then here it's 6a squared b squared, then 4ab cubed, and finally 1 a to the 0 b to the 4th. And of course, anything to the power of 0 is just 1, so you don't actually see these terms normally, but I'm just writing them out for this example. So if you understand how this pyramid works, and you know this simple pattern with the exponents, then you can expand any binomial. And by the way, you'll notice that I did a minus b here instead of a plus b. So because it's minus, our terms will alternate between being positive and negative. So this first term, 1a to the 4th times b to the 0, is positive. Then the next term is negative, then positive, then negative, then positive. And they will always just alternate. So, and if this was a plus b instead, then all of the terms would be positive. Okay, and so now going back to our question. So unfortunately, I don't think there's any systemic way to realize that this expression simplifies to b minus a cubed. You just need to recognize it. But hopefully my explanation about Pascal's triangle, which is what this thing over here is called, can help a little with that. But anyways, so we just found the answer to the first part of the question, so now we can move on to the second part of the question, which says, when the line L is perpendicular to the tangent line to the parabola y equals x squared at the point b comma b squared, express a in terms of b. So, let's look at our diagram here. So we need to express a in terms of b. We know that this blue line, the line between points in a and b, is perpendicular to the slope of the tangent line at point b, which is this red line over here. So using a derivative, we can find the slope of the tangent line to our parabola, so the slope of the red line, which is 2x, right? So yeah, if y equals x squared, then the derivative is 2x, which gives us the slope of the tangent line. And so that means that the slope of the line from a to b is the negative reciprocal, which is negative 1 over 2x. It's just a general rule that you definitely need to memorize if you haven't already, because it comes up a lot in these questions. So if you have a line with slope, say m, then a line perpendicular to that one will have a slope of negative 1 over m. So anyways, that means that the slope of our line is negative 1 over 2x, which is negative 1 over 2b at point b. However, we also know that the slope of the line is b plus a, right? We found that earlier when we were solving the first part of the question. So that means that we can make these two expressions equal to each other. So b plus a equals to negative 1 over 2b. And then if we just solve this for a, then we see that a equals to negative 1 over 2b minus b, and that is the answer to this second part of the question. So finally, it asks, when the condition in part 2 holds, calculate the minimum m of the area S and the value of b at which S attains its minimum m. So we need to find the minimum area, and to do this we need to find the derivative of this area and set it equal to 0. So I already found the area S in part 1, and we just found a in terms of b in part 2, so we have to plug that in for a. That way we can have this expression in terms of just one variable, which is kind of necessary to find the derivative of it easily. So now with this we can find the derivative. So sorry, we have to simplify a little bit first, right? you'll see if, like, the terms combine a little, and so we have this for our area S, and now we can find the derivative of this. So to do that, you're going to do the chain rule. I mean, you definitely should know the chain rule for this exam, so if you don't know it yet, then make sure to study it. It's not too hard. And I'll quickly show this explanation. So we can say this whole thing in the brackets right here is its own function inside of s of x. We can call it h of x. So the derivative of this whole thing, so the derivative of s of h of x, is equal to the derivative of s of h of x times the derivative of h of x. So to find the derivative of this, of s, first we just use the power rule on what's in the brackets. So we don't touch what's in the brackets, and we just use the power rule on it. And then we find the derivative of what's inside of the brackets, and we multiply these together. Now, right, so remember, in order to find the minimum of our area S, we need to make this derivative here equal to 0. And, at first that might look different or difficult, but notice that, all of these things multiply together. And so what that means is if we just make one of the things inside these brackets equal to 0, then the whole expression will equal to 0, right? If we make these brackets right here equal to 0, all of this multiplies together, and 0 multiplied by anything just equals to 0. And so, we'll find what we're looking for. Same if we make the stuff inside this brackets equal to 0. So to start, let's try to make 2b plus 1 over 2b equal to 0. That's from these brackets right here. So, if we rearrange a bit, we end up with this. 2b squared is equal to negative 1 over 2. But this isn't actually a possible answer, right? Because, b squared has to be positive, since squaring any real number gets you a positive answer. Meaning, of course, 2 times b squared is positive. So 2 times b squared cannot equal to negative 1 over 2, or, negative anything. So definitely this isn't the right answer, because it's not even a possible answer. So instead, let's try making this other bracket equal to 0. So 2 minus 1 over 2b squared. So if we make this equal to 0, then we end up with 2 equals to 1 over 2b squared, which becomes, we multiply both sides by 2b squared. You end up with 4b squared is equal to 1, which means b squared is equal to 1 over 4, which means b is equal to plus minus 1 over 2. So we have two possible answers, right? B could either be 1 over 2, or it could be negative 1 over 2. So to figure out which one's the right answer, let's look at the expression for our area again, right? So notice that if we use negative 1 over 2 for b, then 2b will be negative, and 1 over 2b will also be negative. So this whole thing inside the brackets will be negative. When we cube it, it'll stay negative, right? A negative number cubed is still negative. And so our area will be negative, right? But a negative area is impossible, right? You have, area has to be positive. So clearly we cannot use b equals to negative 1 over 2. And so we use positive 1 over 2 instead. So we plug in b equals to 1 over 2 in our area. And then after a little bit of simplifying, you end up with 1 over 6 times 1 plus 1 cubed. That's 1 over 6 times 8, which is equal to 4 over 3, and that is our minimum area M, which is what the question is looking for. Now, you might be wondering how I can say for sure that this is a minimum, since technically when you take a derivative and solve for 0, you could be finding a minimum or a maximum. But, first of all, the thing is we found that there's only one possible answer, right? We ruled out b is equal to negative 1 over 2. So reasonably, that one possible answer must be the answer that the test is asking for, right? It wouldn't make sense for the one possible answer to not be the right answer, because then there'd just be no answer to this question, right? But of course, if you really wanted to make sure, what you could do is you could just try plugging in some other value for b, such as say, 1, and you'll see the area that you get will be greater than 4 over 3, which confirms that this is in fact a minimum. So the minimum area M is 4 over 3, and it occurs when b is equal to 1 over 2, and that is the final answer to this question. So finally is the section 3 question, which says, consider the solid body B formed by the intersection of the two cylinders x squared plus z squared is less than or equal to r squared, and y squared plus z squared is less than or equal to r squared, r is greater than 0 in xyz space. Fill in the blanks with the answers to the following questions. Express the area of the cross-section of B cut by the plane z equals to t, negative r is less than or equal to t is less than or equal to r in terms of r comma t. So before I begin, I just want to say that, I never learned anything like this in school or university or anywhere. In general, we never really learned much 3D geometry, and definitely never anything like this. So while I will do my best to explain this question properly, please just know that I'm a bit iffy on it, so it may not be the greatest explanation. So if you did study 3D geometry before, then maybe you can answer this question easily. I really have no idea if this is considered a difficult question or not. But anyways, let's start. So we have two cylinders and we want to consider the part at which they intersect with each other. Firstly, let's notice how it says x squared plus z squared is less than or equal to r squared, and same with y squared plus z squared. So this is kind of similar to the equation of a circle, which you are hopefully used to. The only difference is that instead of it equaling to r squared, it is less than or equal to r squared. So in terms of a circle, that means the entire circle is filled in instead of just the perimeter. So, normally you have it equaling like this, and so you only get the perimeter, while here you have the entire inside of the circle. So what that means for our question is that our cylinders are not hollow, they are solid. Maybe that's obvious, but I want to clarify why here it is less than or equal to instead of just equals to, which you're probably used to seeing. Also, remember r is a constant here, and since both of these cylinders are defined as being less than or equal to r, that means that both cylinders have the same radius. They're also both centered at the origin. So now, as always, you should try to draw a diagram. Unfortunately, I'm not really an artist, and it's kind of hard to draw 3D shapes like this, especially cylinders, but I did my best over here. So firstly, note the 3D axis in the middle here. So x is from left to right, and z is up to down, and y is into and out of the page. And so we have these two cylinders both centered at the origin, and they both intersect, around the origin, or like the intersection point is centered on the origin. So, and that's what we care about, the intersection part. Also, the question says that there is a plane z equals to t. So what that means is at a value of t, a sort of, big flat rectangle will cut these cylinders. So if t equals to 0, then these cylinders would be cut right through the middle, something like this. If if t, for instance, equals to 1, then the cylinders will be cut a little bit above the middle, something like that. If t equals to -1, then they'll be cut a bit below, and so on. And so we want to find the area of the part of the cylinders that intersect on that plane z equals to t. So to find the area, what's very helpful is to imagine looking at these cylinders from above. In that case, they will just look like two rectangles, since a cylinder on its side from above just looks like a rectangle. And the two cylinders are the same size, meaning that this cross-sectional area right here is just a square. So to find the area, we just need to find the length of one of these sides. So here's a side view of the top half of the cross-sectional volume. So this is a square. This is the square right here, right? This is the same as the square that we had here, which means that is the area that we're looking for. There's also, there are also half circles on these blue sides here, but I'm not drawing them because it's kind of hard to do it and make it look good. But remember, this is, two cylinders. So we have the first cylinder going from like top to bottom like this, or I guess from inside and out of the page. And then we also have the second cylinder going from left to right. So remember that the question tells us that x squared plus z squared is less than or equal to r squared. So for example, let's say that we cut this cylinder at z equals to 0, meaning t equals to 0, meaning it's cut right in half. So that means that at this point right here, the z value is 0, so it's just x, and x squared is equal to r squared. And at this point right here, it's negative x, and the magnitude of negative x squared is equal to r squared. And it's the magnitude because, of course, a distance can be negative. This is still a positive distance, right? It's just towards the negative x. So if that was a little bit confusing, then it might be easier to show the same idea, but just with a circle. So in this case, we have x squared plus z squared equals to r squared, and I set the r equal to 2 just for this. So for our example, at the point 2 comma 0, which I labeled here, we have 2 squared plus 0 squared equals to r squared. Our r is 2. And if you were to choose any other point along this circle, so this point or literally any other point, then you would find that that point's x value plus that point's z value, both squared, would add up to r squared, which is just 4 because r is 2. So both of these points have the x value, x, or in this case, negative x, then this length would just be 2 times x, and sorry, x and my multiplication kind of looks similar, right? Because this right here is x0, right? That's just the very center. So it would be 2 times x, and again, in this case, our x is equal to r, because as we saw here, right, here it's 2 comma 0, so in the case where you're just along the axis, your x value will just equal to the r value. So our x is equal to r, and the magnitude of negative x is also equal to r, which means that this distance is equal to 2 times r, which means that in order to find the area of this square, we just need to take 2 times r and square it. And so the area would be equal to 2 squared times r squared, which is equal to 4r squared. And so, right, and so that's the area of this square when t equals to 0, right? Because our cylinder is being cut right through the middle, which means that t is equal to 0, right? Because z is our, up and down axis, that we're cutting it right through the middle of, that up and down. Of course, the question doesn't want us to just find it when t equals to 0, right? It wants us to find the area for any t. So the next step is to be able to write our side lengths in terms of r and t instead of just in terms of r like we did here. So to do that, we can use the equations provided. So in the question, it says that x squared plus z squared is less than or equal to r squared, as given in the question, and z is equal to t, also given. And so rearranged, we get that x squared is less than or equal to r squared minus t squared. And if we square root both sides, we get that the absolute value of x is less than or equal to the absolute value of this square root. Or put another way, the value of x is between the negative of this square root and the positive of this square root. So what this means, if we go back to our diagram, is that for any t value, which means at any level that we cut the cylinder at, the x value at the edge will be equal to the square root of r squared minus t squared, or negative of that square root on the other side. So let me draw that. And first, let me remove this stuff that I already drew to make it easier. So if we have, right, so let's say we cut this cylinder, let's say our z is equal to -1. So we cut the cylinder right there. And so what that means at this point right here, our x value will equal to the square root of, what was it? The square root of r squared minus t squared. And then at this other point adjacent to it, our x value will equal to negative that square root. And I'm just going to do this symbol right here, just means the same as, so it's still the square root of r squared minus t squared, which means that this length right here is just 2 times the square root of r squared minus t squared. And so if we want to find the area of the cross section with that t, then it's just 2 times r squared minus t squared all squared, right? So our length is 2 times r squared minus t squared. And so to find the area of that square, we just take the length and square it. And so the area B is equal to 4 times r squared minus t squared. And that is the answer to the first part of the question. So next, the question wants the volume of the entire intersection of the two cylinders. So to start, let's simplify by just drawing 2 rectangles instead To be clear, of course, we're still talking about two cylinders, not two rectangles, but this just makes it easier to draw, and the point I make will be the same anyways. So we already found how to find the area of the cross-section cut at a certain point. So for example, if we cut right here, we can find the area of this cross-section. And how do we use this to find the volume? Well, let's say you also found the area of, this cross-section and this cross-section and this one and so on, right? If you add all these cross-sections up, then you will begin to find the volume. So hopefully you can see what I mean here. We need to use an integral to find the sum of all of these cross-sections in order to find the volume. So if we do that, then yeah, we can find the volume, which is what the question's asking for. So we have the integral of the area of the cross-section in terms of t. Remember, r is just a constant. It's the radius of our cylinders, and t is our variable, so that's why it is an integral in terms of t. Now the question is, what are the bounds of our integral? Well, let's just look at one of our cylinders right here. Remember, the two cylinders are the same size, since they both depend on r, so we just need to find the bounds on one of them. If this right here is the center of our cylinder, then this distance is the radius. So clearly we only need to check the integral up to the edge of this radius, since, past it there's no more cylinder. And so the upper bound of our integral will be positive r, because past that there's no cylinder, and the lower bound of our integral will be negative r, right? Because we're going down from the center a distance of r, it'll be negative r, and so that is the bounds of our integral. So this is what our integral looks like. It's as you see, I pulled out the 4, which you can do because it's just a constant, or like you're multiplying by a constant. And so we just use the power rule here. It's a pretty simple integral. And so now we just plug in the values r and negative r. I'm not going to, go through every step, but you can pause to look if you want to see what I did exactly. And so if you plug in these values and then simplify, you end up with 4 times 4r cubed over 3, which equals to 16 over 3r cubed. And that is the volume B, and that is the final answer to our question. So that is it for this exam, and sorry again if this last question was a bit confusing. Like I said, I've never done anything like this before I started studying for MEXT, so and also this, at least in my opinion, this is a very difficult question, so it's a bit difficult for me to try and make it, really simple for you guys, but hopefully I did an okay job. But yeah, anyways, I hope you found this video helpful. If you have any questions about this exam, leave a comment and I will try to help you if I can. And if you're writing the MEXT exam soon, then good luck and have a good day.